diorama, welcome aboard.
Hi plastic lovers, I'm Val, 18 Squad Lab, welcome on the channel. That day couldn't have started a better way. Let's start the business with the building of this Tiger one. So for the beginners now, a few advices. I advise you to start with extra thin glue. The one of Tamiya is excellent. It gives you the advantage to glue your pieces by capillarity, and the drying time is really fast. So you will also need precision tweezers to handle the small pieces, nail sticks. I work all the time with nail sticks. It's much easier than sanding papers. Scissors or wire cutters to remove the plastic pieces from the sprues. A very sharp hobby knife with blades that you can change easily. Not only sharp blades, but also saw blades. It might be really handful to cut some plastic pieces. Another very important tool you will need is the hand drill with different micro drills. It's very important to open holes in plastic pieces, but also to help you sometimes to bend some photoetched parts. More specifically for this kit, you will also need specific tools to create the Zimmerit. You can find the description of these tools in the description below, and you will see later how to use these two tools that I did myself. Another interesting tool is a torch. You can buy a small torch in supermarkets like Intermarché. That one costs about €7. It's nice to burn photo-etched pieces. It will allow you to bend them more easily. With regard to photo-etched work, you will also need cyanoacrylate glues. I use the black slow dry to give me more time to glue my pieces, while the other one, the Loctite, is a common glue you can find in supermarket, and it dries really rapidly. While working with photo-etch, I use generally a small plastic cap from a bottle of Coca-Cola. I put my cyano glue on this cap, and finally I put my glue on the pieces with a metallic needle I did myself. That's a very thin needle that I put on a hobby knife handle. Finally, you also need some metal sanding stick and a metallic ruler. Very important product you need to have is the Tamiya putty basic type that will be used for filling some holes, gaps, but also to create textures. Prior to starting the construction, I really advise you to put some identification stickers on your sprues. It will make your work much easier to identify the sprue you need during the construction. I also advise you to spend a little bit of time to study the instruction manual, especially for this kit from Dragon. The construction starts with all the wheels. Do not cut your pieces with your hobby knife on the cutting mat. Instead, use your scissors to remove the parts from the sprue. That way you will avoid to break parts while pushing on the flexible cutting mat. Directly afterwards, remove the excess of plastic sprue from your wheels, your pieces in general, with your very sharp hobby knife. Watch out for your fingers. On this tank you have 32 wheels, so there is a little bit of work. Above this, you also have injection seam running all over the wheel length, and that will need to be removed as well. Directly after removing the excess of plastic with the hobby knife, just continue with the sanding stick. And that's why I love using them. It's because they have different grains, and you can work from coarse to fine. That will allow you to recover a perfect smooth plastic surface. Moreover, the sanding sticks have a flexible, smooth surface, which gives you the capability to maintain the curvature of the pieces and not creating any flat surface while sanding pieces. That's very interesting. Watch out to select the correct rod types, because there were different rod types in function of your Tiger 1 version. Always execute a dry fit test prior gluing any plastic piece. It's very important to check before gluing that the pieces are adjusting correctly. We continue afterwards with the wheel assembly without any big issue. The fitting of all the pieces is quite good, there is no big issues. You continue with the driving sprocket and later on the tension wheels. When you cannot work with your sanding sticks, just work with normal sandpapers. You can even create your own sanding tools. You will see that later on in the video. Another way of working for sanding is using the hobby knife blade, but watch out with this method because it's really aggressive and it can rapidly create flat surfaces. So try not to use this technique with round shape objects. As I told you at the beginning of the video, a big advantage of the extra thin glue is that you can use it by capillarity. It's a huge advantage because you can dry fit your pieces and directly, without removing the pieces, apply the glue above them. It's really fast and efficient. Some pieces, like the transmission cover, won't be glued immediately because it's more interesting at first to apply the Zimmerit to the armor plates. So I mark these pieces' position with a pigment liner, very thin, and I will glue these pieces later on. Dragon offers the possibility to create the suspension like it was in the real tank. I mean here, working with torsion bars. Personally, I selected the option to glue everything in the right position because I found these torsion bar much too flexible, and I fear that in the future, I mean in 1-2 years, the plastic could suffer from structural fatigue. So instead, I decided to lock the first suspension arm to the actual Tiger 1 ground clearance that was 47 centimeters in the reality, so 1.34 centimeters at scale. And then I glue the rest of the wheel train on a predetermined position, as if the tank was riding over cobblestones, rock debris, sandbags, like in urban areas. It gives to the suspension train a much more dynamic look, but obviously if you put the tank on a flat surface, some wheels won't touch the ground. So it will be required to adapt the diorama ground to the wheel position. A good point for Dragon is the possibility to have an adjustable tension wheel arm. We won't glue it for the time being. Instead, we will keep it movable so that once the Friul metal track will be assembled, we will be able to adjust the track tension, just like on the real tank. The Friul metal track were for me a must-have, as from the beginning of the project, because it gives the model a much more realistic look. The box comes with metallic wire to link the elements together and two little bags of metal tracks. There are 220 metal elements that you need to sand, drill and assemble together. The price to pay is not only a matter of euros, but as well a matter of hours. It took me about 7 hours to correct these tracks one by one. So as I show here, you need to clean the holes for the axis with a little drill. I use a 0.6 millimeter drill to clean these holes, while Friul advise you to use a 0.5. With the 0.6 it was easier for me to insert all the track axis to link all the elements together, as you will see later. Each track element has two hinges that you need to clean with your drill. Watch out that one of these hinges needs to stay tapped on one side, so do not drill it completely. As I said, you also need to sand slightly these metal pieces. It's quite easy, it's very soft metal, and honestly there is not that much work. You sometimes have a little bit of metal residues, but it's really easy to clean with a metallic sand stick. What was a little bit more tricky was to remove the metal residue that were sometimes invading the guiding teeth in the middle of the track elements. That's also one strong point for the Friul tracks with regard to the plastic tracks that you may find in the box. The Friul tracks comes with the guiding teeth that present a hole in the middle, which was the case on the real tank. Dragon, on the contrary, do not provide you with the correct guiding teeth, only for the spare tracks, unfortunately, but not for the complete tracks. It will be then necessary to link all the elements together thanks to the metallic wire that is provided. So for this you need to identify the correct axis length. I use personally a little bit of masking tape. I just insert the axis until the end of the track where it's tapped, and then I put my masking tape to determine the correct length. I reported this length on my micro drill, again with a little piece of masking tape, and I drilled a hole in a wood block, a little wood block. As you can see, there are many holes in this wood block. And just for the little story, this is not a female sign you see on this block, but that these are two holes, one which is rejected by a cross and the other one that is selected by a circle, just for the little story. I now have a template to cut rapidly many axes at the correct length directly with my scissors. Once I have a bunch of metallic axes, I use a folded masking tape to stick on both faces to stabilize my work, and I use it to place my track elements together before inserting the axis in the hinges. As I drilled with a 0.6 millimeter drill, it was rather easy to insert all the axes in between the track elements. I generally worked with 5 to 6 track elements at a time, then inserted the track links completely until the end of the hinges, and continue with another bunch of 5 to 6 track elements. At the end of the process, you end up with a beautiful workable metal track, which will, without any doubt, enhance your model appearance. Once you judge that you reach the correct length, just use a bigger track axis for the 5 to 6 last elements, so that it will be easier later to remove the track elements in excess and to adjust the track length to the tank suspension. Given to the fact that my wheels, driving sprockets and tension wheels are not glued at this time because I need to remove them for painting, it's a little bit tricky to adjust the correct track length. But anyway, with patience, it's possible, it's just a matter of time. Given we've maintained our tension wheel arm free and not glued, we are now able to move the tension wheel forward or backwards to adjust the track tension. And just by removing the track axis in excess, you have directly the correct track length for your tank. To assemble the track, just use one longer track axis, keep it longer so that you can easily insert it and remove it for the painting process. It will be now time to glue your tension wheel arm into the final position. To finalize the whole procedure with the track, just insert one drop of cyanoacrylate glue inside of each hinges extremity where you inserted the axis, so that the metal axis are locked in their hinges. So all in all, the complete process is rather easy. There is no specific difficulty with all this process. The only thing is that it's really time consuming. You have to count around 7 to 10 hours of work to complete the whole process. It's very important to work with anticipation. Here, for example, I start to prepare the aft wall of the hull section by preparing all the different elements like the exhaust pipes, exhaust cover, the jack and different pieces, so that I can underline with my pigment liner their exact position on this armor plate. It will be easier later on while applying the Zimmerit to avoid these areas and maintain an easier fit. I will only maintain one exhaust cover, the other supposed to be torn apart while the tank was maneuvering in urban area. To apply damages to the remaining exhaust cover, I heated the brass metal to red heat with my torch, just to make the metal material more flexible. I also removed some materials with my Proxon rotative tool from the inside. And finally, to make the damages more coherent, I also apply some scratches, lateral scratches, to simulate the movement of the tank against the obstacles. A good way to represent steel texture is to mix some Tamiya putty, basic type, with some plastic glue, and then you apply it with an old paintbrush, and finally, once the mixture is completely dry, you pass quickly with a fine sand stick. Prior applying any Zimmerit on the tank, we still need to prepare some little items on the hull, the machine guns that takes place inside the combat compartment. We have also a few hatches to prepare. We plan to replace all the towing cable, the plastic ones, by metallic ones. And one of the most tricky part, to replace the track cable, which is located on the flank of the tank, by a metallic cable.
This part was really tricky, just because the cable head are very small. These are tiny pieces that needs to be drilled to accommodate the fitting of the metal cable inside of it. It was quite challenging. We continue the work with the realization of some photoetched clamps. These clamps will receive the tools. A good point for Dragon that provide us with a mold in the kit that permits to bend all these tiny photoetched parts into the correct shape. Watch out with these tiny pieces. I must admit that I spent a few moments below the workbench searching for my photoetched parts that just escaped from the tweezers. The front part of the hull unfortunately present a little warping that needs to be corrected, as the front armor plates are not fitting in place. This warping induces a lot of inside pressure on the elements, so I decided to correct it with the remainder of some evergreen profiles that I had in stock. That way I was sure that this pressure won't break parts in the future. Okay, I was ready for a Zimmerit application, and with this regard I was a little bit confused about the way I would follow to realize this work. A friend of mine did it with a soldering iron, melting the plastic, but it was no option for me because, while you start melting your plastic kit, there is no room for any error. You can destroy it. So given it was the first time for me, I searched for other options. I first did some tests with Magic Sculpt, which is a two-component epoxy putty, but it was too dry and too hard to shape into the correct form. So after a few trials, I quickly abandoned this idea, and then I tried with Tamiya epoxy putty. Basically, it's quite easy. You have two components that you have to mix with equal parts to create one mixture. I advise you to create a little ball of more or less 1 centimeter diameter. With this little ball, you can work for about 1 hour. As from 45 minutes on, the mixture starts to become more solid, and it's more and more difficult to apply it correctly. I then subdivided this ball into smaller fragments, and I spread out these fragments on the tank surface with the aid of a toothpick. Now, this mixture is quite sticky, but there is a way to reduce this issue. The best insulator I found to reduce or cancel the stickiness of this mixture was water. I also did some tests with baby powder, but even if the stickiness was reduced, it was still an issue. So actually what we want is to have a maximum of stickiness with the tank surfaces and a reduced stickiness on the outer surface to reduce the stickiness with your fingers, with the toothpicks, and furthermore with the Zimmerit tools. So the final result after many trials was to use a little bit of humidity and not to work with wet surfaces, which would completely cancel the stickiness of the product and its adherence with the tank surface. For the toothpick, the best way is to keep it humid by putting it in your mouth on regular intervals and to remove the excess of water with your hand. That way your toothpick does not adhere to the mixture and you can use it as a pastry roller. Exactly as if you were preparing a pie, you just use your toothpick to spread out the mixture evenly as you could, and you try to spread it out to make a very, very thin layer. So just for the historical context, the Zimmerit was a layer of 6 millimeters on the real tank. That means that at scale, your mixture cannot exceed 0.17-18 millimeter. So you have to spread out your mixture with your toothpick until a point where it becomes almost transparent. So you have the time to spread out your mixture. Personally, I felt more comfortable by first spreading out my mixture evenly on a white surface, and then only after a few minutes starting to give it the correct shape with the Zimmerit tools. That way the mixture already had a little bit of time to dry and to stick more to the tank surface. Just like your toothpick, your Zimmerit tool needs to be moistened at regular intervals. I usually did it each 2 to 3 lines of texturing. To do this, I just dip the tool inside a glass of cold water and I remove the excess of water with a paper towel. For tighter spaces, you can use the smaller tool to texture your Zimmerit, or a micro screwdriver. It's really handful to access the smallest areas of the tank. Should your Zimmerit tool be clogged with mixture, with the putty, you can easily remove it with Tamiya lacquer thinner. With an old paintbrush. It's quite easy to recover rapidly a very clean Zimmerit tool. One of the trickiest part of this construction was the cable that runs on the left flank of the tank, and that was used apparently to replace the tracks of the tank that were really heavy. Using toothpicks inserted in styrofoam, you can easily reproduce the original shape of this cable. Afterwards, it's just a matter of patience to place this cable on the flank of the tank. I started from its left extremity on the attach point on the hull, and then following the plastic cable reference, I just travel with the cable along all the supports, the metallic supports, alongside the flank until the other extremity. For this task I used cyanoacrylate glue, Loctite, so the fast drying one, just to get a rapid grip on the supports. Once reaching the end of my cable, I had to remove a little bit of Zimmerit to glue on the flank the attach point of the cable. And finally, to get a smooth transition between my attach point and the surrounding Zimmerit, I just fill in the gaps with a little bit of Tamiya putty that I cleaned with a Tamiya lacquer thinner. All in all, it was a stressful experience, but I really love the result. It's much more authentic and realistic than the plastic one. The remainder of the hull work is no big difficulty. I just put on the hull all the different elements that needed to be glued, with the exception of the exhaust, because they will need to be painted separately from the hull. All the other pieces of equipment will be permanently glued to the tank with cyanoacrylate or plastic glue, and will be painted in one block during the tank painting. I decided to experiment soldering the photoetched part for the first time. My decision was to go for the metallic side skirts in order to be able to create much more realistic war damages. I first burnt my side skirts to red heat in order to make them much more flexible. Brass foils are really rigid, and that's the only mean to manage to bend them on an easy way. It's to burr them at first. Before soldering, you need to apply some flux on your pieces to remove the oxide films that forms on their surface. It will increase the bond of your pieces. Only after you can apply your tin. The biggest advantage of soldering is that it greatly improves the robustness of your construction. You cannot reach an equal robustness with cyanoacrylate glue, and that's the reason why I decided to experiment soldering. Now, I have to admit it was my first time, and there is a huge space for improvement. But at least I tried, and I succeeded in constructing robust assembly. With regard to the fitting of the side skirts on the tank's flanks, I opened a trench with my razor saw within the Zimmerit. And afterwards, I just simply put my side skirt within these trenches, and I super glued them with cyano black slow dry. And for a seamless transition with the Zimmerit, I just decided to apply a diluted layer of Tamiya epoxy putty with a paintbrush that afterwards I cleaned with Tamiya lacquer thinner. The final touch to this hull construction, after almost 2 weeks of work, was the construction of the frontal mudguard. I decided to go only for one on the left side, just to increase the damages to the tank. And these mudguards are super detailed. It's a nice work from Dragon, and are completely done with photoetched parts. The turret work was much quicker. To erase the gluing seam on the gun muzzle brake, I used cyanoacrylate that was sanded afterwards, after complete drying. That's the best way to erase gluing seam. That's also the technique that I'm using to erase the gluing seam on the wings leading edge and on the fuselage dorsal spines of my aircraft. The aluminium gun barrel provided in the box has to be inserted in the recoil system in the turret. It is blocked in position by a tiny plastic piece, So for safety reasons, I decided to insert within the recoil system a piece of plastic sprue. That way, no risk to see our beautiful gun getting loose in the future. The gun mantlet received a Zimmerit coating, just like the rest of the tank. Exactly the same procedure. Watch out here with the different shapes of this mantlet. It's not linear, and you have a lot of spaces where the putty mixture can accumulate. So watch out to spread out your putty coating on an even manner and to maintain the thickness to the minimum. The fitting of the gun was quite easy. Just pay attention to the correct positioning of the gun muzzle brake, on which you have a reference point on top of it. This reference point needs to be aligned vertically in between the two lateral markings of the gun. That's the correct positioning. The rest of the assembly is quite easy, and even the recoil system is functional. The rest of the turret fitting is really easy. Just watch out to select the correct pieces regarding the hatches and the cupola of the tank commander in function of your tank variant. The loader episcope slot needs to be sanded heavily to give space for the episcope and to give it the opportunity to protrude nicely on the turret's roof. To sand a round-shaped object, it might be necessary to create your own sanding tools. So here, for example, just a small wood stick, a little bit of cyanoglue, and you glue sandpaper at the extremity. Personally, this wood stick has a 400 grit on one side and a 1000 grit on the other side. It gives you rapidly the capability to correct a plastic piece inside a curvature. The loader hatch receives its Zimmerit coating, a side of the turret Zimmerit coating. And just like for the hull, we will draw on the turret's flank the shape of the different objects that will be glued and where no Zimmerit has to be applied. Finally, when the turret is ready, we apply the Zimmerit coating, just like we did for the hull. And we will terminate this turret by applying all the different little elements that comes on its flanks, like the Rommelkist and the different spare tracks. Well, last but not least, the battle damages. To realize these scars, I will work with a historical picture. It's the best way to assess how deep were the shell impacts on the different armor plates of the Tiger I, but as well how looked like these shell impacts according to the different calibers and the location where these shells impacted the tank. As a common rule, I will first drill with my Proxon rotative tool and different drills the main hole, the main impact. Furthermore, I will remove part of the Zimmerit coating in the direct vicinity of this impact, and finally I will fill in the impact hole with a little bit of putty and press it with a wood stick just to create this kind of melted iron color around the impact hole. I applied 5 or 6 impacts on the hull at different locations and with different shapes. And for the smallest impact, I used a toothpick to push the putty inside of the holes. For the very small arms fire, I did not use any putty at all. Sometimes for some shell impacts, I also use the Tamiya extra thin glue just to melt a little bit the plastic residues around the impacts. I think it's also important to create a logical link between a shell impact and the different damages around it. I decided, for example, to place one shell impact on the left side to justify the loss of the side skirt that could have been blown away by the impact.
So, 2 weeks later, we started with a coffee. Let's finish with a beer. My Tiger One is finished. At least the building of the Tiger One is finished. So I'd like now to resume a little bit these 2 last weeks. The building of this kit is not a piece of cake. There is a lot of work. So I think the Dragon kit, even if it's already 17 years old now, it's a kit from 2005. This kit is really outstanding. The quality of the details, the precision, the fitting of all the pieces. I have almost nothing to say. It's as good as Tamiya. You have the same level of quality. Putty is almost not necessary. The fitting of all the big components together was quite easy. Now, to my point of view, I would not recommend this kit for beginners. I would rather say, if you are starting with skill modeling and you are unsure about tank building, I would say go for Tamiya or another brand. The big issue with this model is the instruction manual. For me, it's really not good. Skill modeling is a big part of skill modeling is planning. I spend a lot of time studying, analyzing the instruction manual very much in detail before building anything. And despite this, it was a complete chaos. Yes, I said the instruction manual is really messy, it's confusing, for me it's not acceptable at this level of quality. I mean, the instruction manual for such a model, when you look at this, I think Dragon wanted to insert too many details per page, and that's an error. I mean, they should have gone with 1, 2, or 3 pages, additional pages to help people and separate clearly the different versions. One of the most complicated moments of this building for me was the creation of this little cable here. That's not a towing cable. It seems that it was a cable used to manipulate the tracks of the tank, because these tracks were really heavy. That was probably, to my opinion, the most tricky part in all the process. Zimmerit was not that difficult. It's a long process. You have to be patient. It's not something you can do like this. You have to count about 1 hour 30 minutes per side. The Friul tracks, the metal tracks, were quite easy. Again, here it's not a matter of difficulty. There is nothing difficult to do that. My son could do it. It's just a matter of time. Again, it took me about 7 to 10 hours just to do those 2 tracks, the metal tracks. To give you an idea, it took me about almost 2 weeks to do the hull and about 2 days to do the turret. So almost the whole work basically is the hull construction. Turret was basically quite easy and quite rapid.
So I really wanted to tackle as well the soldering of photoetched parts. That was for me the first time, but to me it was important to test, because you know, working with metal parts, especially photoetched, give you more smoothness, more precision, more sharpness with regard to damage creation, with damage realism, and the fact that you go for soldering give your pieces, your metal pieces, more strength to resist the damages you are doing. You can bend the metal plate almost as you want without breaking anything. You cannot maintain this resistance to damages with cyanoacrylate glue. It's impossible. Well, I hope you enjoyed the video and the building process of this Tiger One. Do not hesitate to leave your comments, suggestions, tips and tricks, ideas to the community. I will also be very pleased to answer your question if I can, if I may help you. Please subscribe to encourage me to continue, and see you next time in the next video. That will be the painting of this monster. I will do a second video for the weathering, because these are two steps, important steps that are quite different. So greetings from Portugal, see you next time, ciao.